Welcome to G Fun Facts Online. Today we are diving into a cold case that sat unsolved for over 2,000 years, starting with a single, careless mistake made by a master craftsman around 350 BCE. Imagine a shoreline on the southern rim of the Baltic Sea, long before the Roman Empire reached its peak. An Iron Age boat builder is at work on a sleek, predatory war canoe. This is a masterpiece of ancient engineering, built without a single iron nail. Instead, its wooden planks are sewn together with lime-bast cords. Because it is flexible, designed to slither over the choppy Baltic waves, it inevitably leaks. All boats of this era leaked. To fix this, the builder holds a glob of warm, viscous pine pitch. He finds a tiny gap in the stitching and presses the sticky black substance into the seam to seal the wood. In that split second, the microscopic valleys and whorls of his fingertip press into the cooling tar. He pulls his hand away, completely unaware that he has just signed his work. He couldn't have known that this boat would soon carry warriors to a violent doom, or that it would be captured, smashed, and sunk into a sacred Danish bog as an offering to angry gods. And he certainly could not have known that 24 centuries later, a team of modern scientists would peer at that tiny smudge of black resin and find his exact fingerprint. This is the incredible story of the Hjortspring boat, the oldest plank-built vessel in Scandinavia. To understand how a simple fingerprint survived the relentless march of time, we have to look at the vault that kept it safe: the peat bog. The landscape of Northern Europe is dotted with these watery archives. To most people, a bog is just a treacherous swamp, but to archaeologists, it is a miracle of preservation. The secret lies in sphagnum moss. This plant acts like a giant sponge, and as it pulls nutrients from the water, it releases positively charged hydrogen ions, drastically dropping the pH level. The resulting water is incredibly acidic. As the moss grows and dies, it also releases a complex sugar called sphagnum. This chemical reacts with organic compounds, essentially tanning protein like leather and cross-linking molecules to prevent decay. It strips calcium from bones, turning them completely rubbery, but it preserves soft tissues, wood, and polymers like pine pitch with terrifying perfection. The bog halts the biological clock entirely, forming a low-oxygen tomb where the ordinary rules of decay simply do not apply. The resurrection of the Hjortspring boat began in the late 19th century on the Danish island of Als. Peat cutters working in the bog began unearthing oddities like iron spearheads and strange wooden planks. For decades, these were just local curiosities. But in the 1920s, the National Museum of Denmark sent an excavator named Gustav Rosenberg to investigate. What he found completely redefined Northern European history. He didn't find a Viking ship. He found something far older and, paradoxically, more complex. It was a giant war canoe, nearly 20 meters long, with strange beak-like ends that curved upwards, resembling the antlers of a stag. Excavating it was an absolute nightmare. The wood had been submerged for over 2,000 years and had the consistency of wet cardboard. If it dried, it would crumble into dust. With infinite patience, Rosenberg and his team excavated the timber bit by bit, using water jets and paraffin wax. Surrounding the boat was a mass grave of weaponry, including 169 spearheads, 50 shields, advanced Celtic-style swords, and incredibly rare chainmail coats. It was the equipment of an entire army, ritually destroyed and cast into the water. When the boat was finally moved to Copenhagen, conservators used the standard method of the time, impregnating the waterlogged wood with alum and glycerin to harden it. At the time, this was a triumph of conservation that saved the physical structure of the boat, but it contaminated the wood on a molecular level. Decades later, when radiocarbon dating was invented, scientists realized this alum treatment was a curse. Carbon dating relies on measuring the decay of radioactive carbon isotopes, but the chemical preservatives introduced modern carbon and completely scrambled the isotopic signature. For a century, the Hjortspring boat sat in the museum as a silent, visually stunning enigma. We knew it was a pre-Roman Iron Age warboat, but we didn't know exactly when it was built or where it came from. The wood was lime, also known as linden, which grows natively in Denmark, but the design had absolutely no local parallel. The monumental breakthrough came in the early 2020s when a team of researchers from Lund University in Sweden and the National Museum of Denmark, led by archaeologist Michael Fauvel, decided to reopen the cold case. Knowing they couldn't test the main hull, they went deep into the museum's archives looking for leftovers from Rosenberg's original excavation. Tucked away in dusty storage boxes were fragments of rope, loose wood chips, and lumps of the black caulking used to seal the boat. These fragments had been deemed too small or insignificant to treat with alum back in the 20s, meaning they were chemically pure. The first major discovery came from the rope. The Hjortspring boat was a sewn boat, meaning builders drilled holes along the edges of the planks and threaded rope made from the fibrous inner bark of the lime tree to pull them tight. Because these leftover rope fragments were untreated, the modern team could finally radiocarbon date them. The results proved the boat was built between 381 and 161 BCE, a time of massive social upheaval and migration in Europe. But the real treasure was hiding in the black lumps of caulking. The researchers placed these tiny fragments, some barely the size of a coin, under a high-resolution 3D microscope. They expected to see wood grain or sand. Instead, they saw a friction ridge impression, a perfectly preserved human fingerprint. The hot tar had cooled rapidly, freezing the microscopic ridges of the builder's finger in plastic perpetuity. The discovery shattered the typical distance of archaeology. We often talk about Iron Age people as a faceless collective, but this fingerprint belonged to a specific individual with a specific job, feeling the cold air and smelling the pungent pine forests as he worked barehanded. But the scientific marvels didn't stop there. The team used gas chromatography mass spectrometry, or GCMS, to analyze the molecular composition of that exact piece of caulking. This machine works by vaporizing the sample and measuring how long it takes different molecules to travel through a tube, allowing chemists to identify the exact chemical fingerprint of a substance. They discovered the caulking was made of pine pitch, mixed with a little bit of animal fat, likely added to keep the tar pliable so it wouldn't crack in freezing seawater. This specific chemical recipe was an absolute bombshell. Why? Because in 350 BCE, Denmark did not have pine forests. The Danish landscape was dominated by deciduous trees like oak, hazel, and alder. Pine trees had retreated north after the Ice Age and wouldn't return until modern forestry plantations planted them. The nearest abundant pine forests were on the Scandinavian peninsula or the southern coast of the Baltic Sea. This proved a long-debated theory. The Hjortspring boat was not a local Danish vessel. It was an invader from hundreds of kilometers away. The boat itself was a highly specialized war machine. Weighing only about 530 kilograms, it was incredibly light for a 19-meter vessel. A modern replica can actually be lifted and carried by its crew, making it the perfect amphibious craft for bypassing rapids or dragging across narrow strips of land. The hull, made of sewn lime wood planks, was not a rigid shell, but a flexible skin that literally snaked over the short, choppy waves of the Baltic. Furthermore, it was propelled by paddles, not oars. When you row a boat with oars, you face backwards and rely on someone else to guide you. But when you paddle, you face forward. You see the enemy and the shoreline approaching. While oars give more leverage, paddles allow for complete silence and instant maneuverability. A synchronized crew of 20 paddlers could stop the boat instantly or spin it on a dime. Adding to its agility, the boat was double-ended with a steering oar at both sides, so the crew never had to turn the boat around to reverse course. They simply turned on their benches and paddled the opposite direction. This was a tactical stealth craft designed for surprise beach landings. Armed with the forensic evidence of the boat, the weapons, and the geographic origin of the tar, we can vividly reconstruct this fateful ancient raid. Imagine late summer on the Baltic Sea. A fleet of at least 3 or 4 of these stealth boats glides toward the coast of Als. The invaders have paddled for days, navigating by the stars and the rugged coastline. Among them might be the man who left his fingerprint, perhaps making a desperate repair to a leaky seam on a beach the night before the attack. They are seasoned fighters, a warrior aristocracy adorned in high-status gear looking for cattle, slaves, or territorial dominance. But as they beach the boats and storm inland, the element of surprise completely vanishes. The local Danish tribes are waiting. The pre-Roman Iron Age was a time of intense tribal friction, where reputation and land were the ultimate currencies. The defenders marshaled their own forces, creating a wall of wooden shields and unleashing volleys of iron-tipped spears. We do not know the exact details of the battle, but the outcome is undeniable. The invaders were completely obliterated. The sheer volume of weapons recovered from the bog tells a story of total, devastating defeat. The locals captured the surviving warriors, their advanced Celtic swords, their incredibly rare chainmail, and their prized stealth boats. In the ancient world, victory was a gift from the gods, and the gods demanded their cut. The victors gathered the spoils of war and dragged them to the edge of the sacred Hjortspring bog, a liminal space believed to be a gateway to the underworld. They systematically and ritually killed the weapons to ensure they could never be used against them in this life or the next. They bent the iron swords, smashed the wooden shields, and snapped the spear shafts. Then, they dismantled the enemy's prized boat, slashing its lime-bast sewing, filling the hull with heavy stones, and pushing it out into the dark, peaty water. As the boat sank into the anaerobic mud, the fingerprint sank with it. For 2,400 years, empires rose and fell. Kings ruled and died. But the low-oxygen, highly acidic environment of the bog kept that tiny piece of pine tar in a state of absolute chemical stasis. Pine tar itself is a natural polymer, acting much like modern plastic when cooled, which naturally repels water and bacteria. If that boat had been left on a beach, The sun and air would have destroyed the fingerprint in a matter of months. Instead, it waited in the dark. The rediscovery of this print highlights the immense value of legacy data in museums. Gustav Rosenberg in the 20s didn't have micro-X-ray fluorescence or high-resolution photogrammetry. He couldn't have known that boxing up leftover dirt and tar would eventually solve the mystery of Scandinavia's oldest wooden boat. Modern researchers took hundreds of microscopic photos from different angles to build a perfect three-dimensional topographical map of the ridges without even touching the fragile artifact. They measured the ridge density, confirming the statistical likelihood that this was a male builder or a robust crew member. The Hjortspring fingerprint completely rewrites our understanding of European prehistory. It proves that Iron Age societies were undertaking highly complex, long-distance maritime operations, using the Baltic Sea not as a barrier, but as a superhighway for war, trade, and communication. It shows the movement of critical resources, like pine tar, across vastly different ecological zones. It also reveals a deeply stratified society, where chieftains wore imported armor and commanded fleets of technologically advanced, custom-built stealth canoes. Think about the logistics of building just one of these boats. Without iron saws, they had to meticulously cleave giant trees into thin, uniform planks using axes. Making the lime-bast cordage was a massive industrial effort, requiring the entire community to strip bark, soak it in water for months, and twist the fibers by hand. These craftsmen understood the precise chemistry of mixing pine pitch and tallow for waterproofing. But beyond the science, the tactics, and the history, there is the anonymous builder himself. We will never know his name or speak his ancient language, but we know he had rough hands stained with black tar, smelling of smoke in the deep pine forest. A sword or a shield is a tool, but a fingerprint is the actual person. It was an accidental monument, a slip of the hand, that became the most intimate connection we could possibly have to a world that has completely vanished. It forces us to realize that the biology of being human hasn't changed. That Iron Age man felt the same cold, the same sticky heat of the tar, and the same adrenaline of war that we would today. The Hjortspring touch is a greeting across the abyss of time, preserved in the black blood of a pine tree, waiting thousands of years just for us to notice. Next time you look at your own fingertips, think about the marks you leave behind every single day, and how one tiny smudge could outlast everything you know. Thank you for listening to G Fun Facts Online. Keep exploring the incredible mysteries of our world.